In chemistry, the last time we talked about element and atom, where we had to understand the basic difference between element and atom. Today, we will continue to focus more of atom because we realize that it's atom that take part in a chemical reaction. So it's very important for us to know the general structure of the atom. So what we have here is a basic general structure of the atom, how we see it before getting into senior high school. Let's revise that and get some useful concepts from there because they are still useful for us. So the example that we have here is carbon atom, and we see what we have within here, something clustered inside. I'm going to draw a busy circle around it. So that structure within, where the protons and neutrons are, we call it the nucleus. So the nucleus is at the center of the atom, and there are this circular thing around. I'm not talking of the green balls, but the lines around. So each line is called a shell. A shell. So shell, that's what we knew before coming, but here we are going to be introduced to other names. So a shell, or orbit, or we have energy level. Energy level. Yes. So this is, so yeah, this is a shell. This is another shell. This is an inner shell because it's within. This is the one that's outside. So we call it the outer shell. So let me just label these two as shells. So yes, so they are all shells. So even among the shells, there is one, the one that's outside. We call it the outer shell. Outer shell. So we call it outermost shell. Outermost shell. Meaning the one that is mostly outside. So meaning the one that's generally out. So outermost shell, or the name should be valence shell. So when we are talking of the valence shell, or is the same as the outermost shell, that's the shell that is very, very out, the largest shell. So any other shell that is inside, this time we have only one inside. So any other shell that is inside, we are going to call it inner shell. So inner shell, or you can call it core shell. Core shell. Usually they are not one, there are more. So let me just, let's say the nucleus is inside, and there are shells around this atom. So let me draw three, or no, let me draw four to illustrate. So in this case, so this is the nucleus in the center. So this is the nucleus, and then here we have the largest shell is called the valence shell, or the outermost shell. So this is the valence shell. All the other shells that are inside, all the other shells that are inside, they are collectively called inner shells. So these are inner shells plus this. So they are all called inner shells. Inner shell. Or you can call it core shell. Right? Now, because this one, the very one that is closest to the nucleus, someone we all usually call it innermost shell. Innermost shell. So when you are talking of the innermost shell, is that smallest first shell within the atom. Outermost shell, that's the largest last valence shell. That's outermost shell. So when you say valence shell, so the term that we use mostly is valence shell, valence shell, valence shell. Very good. And the inner shell, innermost shell is that one, the very first shell. And the inner shell, when you talk about inner shell, the core electrons, meaning they are within all the shell that are within, aside the valence shell. Everything, any other shell that is within the outermost shell is called the inner shell, or the core shell. because bearing their name, the names that so they have electrons, right? Each shell has electrons, so electrons are located on the shells. So these shells house or they hold these electrons. So the names of the based on the position of the atoms of the electrons on these shells, the names also follow. So those electrons that are found on the outermost shell or they are found on the valence shell, we call them valence electron. Valence electron. So valence electrons. Valence electron. So this is a valence electron. This is another valence electron. This is another valence electron. Valence electron. Why valence electron? Because they are found on the valence shell or they are found on the outermost shell. So if if you want to talk about the electrons on the inner shells, you call them inner electrons or core electrons. Because we said the shell name is inner shell. So or the core shell. So the electron that are on it, we call them inner shell or inner electrons or core electrons. So core electrons, we are referring to all those electrons on the inner shells. It may be one, two, or three. They are with different shells. So any electron that is found. So based on your position of the electron, the name also changes. So if the electron is on the outermost shell, we call it valence shell or valence electrons or outer electron. If the electron is on in the any of the inner shells, it's called inner electron or core electron. So all the electrons that are within all the electrons that are within the inner shells, those electrons that are not the outermost shell, right? Those electrons that are not on the outermost, all of them are called core electrons. The one that are on the outermost shells, we call them valence electrons or outermost electrons. I've been mentioning electron, but we are seeing a proton, neutron here. Let's talk a bit about them. So we have finally established that we can all see that the electrons are on the shells, right? But there's this cluster of particles here containing it's labeled protons and neutrons. So you see, if you look within this, the red balls, the red ball are red. There's no charge inside. So when I mean charges, you see plus here, and the electron you see minus here. So electrons are negatively charged. That's what it means. And then the protons are positively charged. So the protons are the one that are positively charged. Positive, 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 positive. But then the protons, they don't associate directly with the electrons on the outermost shell, but their location is within the nucleus, right? So neutrons and protons are within the nucleus. So what happens is this is a positively charged, right? Positive and negative charges attract. Opposite charges attract. So protons are positive, right? So this proton will associate with this proton. This proton will also associate with this electron. Sorry. This one will also associate with this electron. This one will associate with this one. This one will associate with this one. There should be one. There should be one within because there are 6 electrons, right? They say there are 6 protons, but I have one, two, three, four, four so far. Four so far. One, two, three, four. To one, two, three, four. Okay. It should only one proton to one electron at a time. So there should be one proton again for this guy. Oh no, this proton has been associated already. So there should be other proton. I think they are within because they are hidden they are under the cluster. So yeah. So each proton and each electron will be associated by a bond, right? They'll be connected. So this proton and this one will charge. So this one and this, because they are oppositely charged, plus one and minus one will give you zero. Plus one and minus one will give you zero. So they'll be balancing. Every positive will be balanced by any negative. Every positive will be balanced by any other negative. Positive and negative, positive and negative. At the end of the day, the total charge on the entire atom will be zero. At the end of the day, the total charge on the entire atom will be zero. Because if you go within the atom, every proton has a counterpart wife. You can see it as the proton is a husband and then the electrons are the wives. So each proton has a wife, right? They are balanced. they are balanced. Each proton is balanced. So plus one proton and minus one electron. So plus and minus, plus one and minus one, the sum will be zero for each pair. For each pair, that will be what will happen. So it's zero, 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 zero. At the end of the day, the entire atom has a charge of zero. So the net charge, we call it the net charge. The net charge. So the net, because we are talking about the resultant or the final charge on the entire atom after everything. But within the atom, there are charges. So those charges are the protons and the electrons. Net charge will be zero, right? So meaning each husband is paired with a wife. Each husband is paired with at least one wife. So it should be one wife. So each husband and a husband. In that case, the net charge, there's no husband left. There's no excess husband or there's no excess wife. So in that case, since everybody is zero, no one is left. So zero. Zero is telling you that no one is in excess. Everyone is balanced. So the number of protons and the number of electrons are the same. If the net charge on the atom is zero, such an atom is called a neutral atom. Such an atom is called a neutral atom. In case there is any imbalance where maybe there is excess proton on electron, there is more wife than the husband, or there is more husband than the wife, what we are going to form are going to call ions. That's when we form ions. We'll go into that later. So just get that understanding that ions is because what the pairing is not equal. The number of protons is not equal to the number of electrons. That's what happened. So what happens to the neutron then? Neutron does not have charge, right? So electrically it will not be attracted with uh, the protons. So but it will be located within the nucleus. Is the proton and the nucleus, and then is the proton and the neutron that are found in the nucleus, while electrons are found on the shells. Good. Now let's analyze something. Get the
Do not miss the next concepts. Why don't you subscribe to keep notified of new videos and concepts?
we talk about protons, right? Protons. We talk about the neutron, and we talk about electron. So we are now going to actually find a difference between them. So these three particles, so they are the particles that are found within an atom. The particles of an atom. They are the particles within an atom. So we are going to actually talk about in terms of their charge, right? So in terms of their charge, um, in terms of their mass and location. Finally, location. Let's show the location in the atom. So protons, where are they located? So we can see that they are located within the nucleus. So say inside nucleus. That's where they are. Neutron, yeah, they are also inside the nucleus. So electrons, they are on the shells, or into brackets outside the nucleus. Outside the nucleus. Or you can write or. So outside the nucleus, on the shells, right? Or on the orbit, or on the energy level, as we said it. Now let's do something about the mass. The mass for proton, where the mass is going to be in terms of atomic mass units. Okay. So I'm going to divide this into two. So whatever I have, so under charge, whatever I put here is going to be relative charge, and whatever I put here is going to be exact charge. The same thing apply for the mass. So whatever I put here is relative charge, and whatever I put here is the exact charge, exact mass. So now for charge, protons, what's the relative charge? The charge is plus one. Um, so this charge will be in coulomb, right? And then neutron, the charge is, it doesn't have any charge, so it's zero, the relative charge. Electron, the charge is -1. This side of the charge, you see, I divided the charge into two categories, two columns, right? So the very first column is for relative charge. The second one is going to be the exact charge. So the exact charge of proton is plus 1.602 times 10 to the power minus 19 coulomb. This is so 1.602 times 10 to the power minus 19 coulomb. That's neutron is still zero. It doesn't have charge at all. Electron is just the opposite, minus 1.602 times 10 to the power negative 19. The same thing as neutron. So this is the exact charge. You might use it later, but plus one and negative one are what we are going to be using at the level. That's why it's called relative. Relatively, meaning comparing relative to each other, what will be the charge. So relative charge is here and the exact charge is here. Let's go to the mass. Atomic mass unit for proton will be 1 AMU. For neutron will be 1 AMU. For electron it is 0. Remember, this is relative charge. Now let's go to exact charge, exact mass. So for the exact mass, for proton, it's 1.0897879. For neutron, 1.0897. Electron is 1/1840. So 1/1840 is zero, actually 0.00 what other number. So approximately that's why we get to zero. But it has an actual value, but the mass is very, very insignificant. It's very insignificant. That's why we actually don't consider. So the mass of the electron is generally considered to be zero. So you will see that proton and neutron, the 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 relative mass of this is exact mass of 1.0879 and 1.0897. You see that even between the two, this guy's value is smaller than this guy's value. So meaning that within the atom, neutron is the one that has the highest mass, the greatest mass than proton. So neutron counts in terms of mass, neutron counts before proton and proton follows electron. So the heaviest atomic particle to the heaviest atomic particle is the neutron. The heaviest atomic particle is neutron. Now let's go back to the atom. You see that all those that have mass, like significant masses, they are found in the nucleus. They are not found on the shells. So in the core there, it's like the entire mass of the atom is concentrated at the center. Is concentrated at the center, right? Because all those particles that have masses are the protons and neutrons, and all these particles are found only in the center or in the nucleus. So the mass of the atom is concentrated within the nucleus. But if you consider electrons on the outermost shell, they don't have mass, like relatively, so zero. So the mass that it doesn't play any role. They are found on the shells, freely moving around, while the mass of the atom is concentrated in the nucleus. So if you want to measure the mass of this atom, you are basically measuring the mass of the nucleus. Yes. So this is the table that gives the basic difference between the two. But what you need for your exam when it's asked, don't use the exact masses. It's not for that. Don't use the exact masses. Just use the relative masses and charges. So you just proton, neutron, electron, then you fill in the relative one, the mass one, and the location. Then you are done. This one to just give you idea, especially at the mass level, to give you idea of which one is the heaviest. So neutron comes before proton, before electron in terms of mass. In terms of mass, yeah. So neutron wins, followed by proton, and these two guys are found in the nucleus. So the nucleus is the one. The nucleus is the particle that hold the mass of the atom. So if you are measuring the mass, meaning you are just basically measuring the mass of the nucleus. Thank you. See you in the next video where we explore more concepts. Subscribe.
Do not miss the next concepts. Why don't you subscribe to keep notified of new videos and concepts?